Hello, welcome back. So in this lecture, we are going to continue our discussion about Q, so Java Q, okay? And in this example, it's Java collections Q. So this Q is from Java collection. Okay. And if we want to use the queue, and if you recall, in Java collections, the queue is an interface. Right? It's not a concrete class. Okay. In order to use it, we need to also import the queue from Java utility. Okay, dot queue, and also linked list. And we also import iterator and render. Okay. Let's take a look. How do we use queue? Our collections queue. Okay, so this is a variable, and the type is an integer queue. Okay, and this is a wrapper integer class. Okay. And we create the queue use a class, concrete class called linked list. Okay, so we use a linked list to create an instance for the queue. Because in Java, this linked list, it's implemented using linked approach, okay, not the array implementation. And it support all of the enqueue and dequeue operation. Okay, so that's why you can use a linked list as a queue. We can kind of borrow linked list for our queue data structure. Okay, and so what over here we do is we generate some random number, and we get 10 out of them, and to add those random number to our queue. So in Java collection, if you recall, we have two set of in-queue add. Okay. And for the add, if it's you cannot add, then it will throw the exception. And after we add, then we can do the pick, okay, to get to the first item. And we can also output the queue. And I already ran it, so we can take a first look what of this. Yeah, so the first item is 11. Okay, so those are the remaining 9 items in the queue. And then let's see what we do next. What next is try to do is try to do the for each loop. Okay, so in Java Java collections for the queue it support it implement the iterable interface. That's why over here we can directly go ahead to use it for each loop. Okay. And we can see the item, yeah, the output is the same as the previous one. Okay, so this is for each loop. Let's see. And then what next we do is we can also directly get the iterator. Okay, so it basically will start at the beginning. So we get the iterator, and then you can continue call hasNet and next. Okay, so basically it also do the loop, but here we use iterator to do the loop. And what next we did is, yeah, we do the iterator again, and then we can also, in the iterator, it also has a method you can call it for each remaining, okay? And over here, what we do is we use a lambda expression, okay? So we want to output item, but we want it following certain format. Is it? If you want to do that, then you can use a lambda expression to achieve this requirement. Okay. So over here, we can call this for each remaining item also. So here this shows us in the Java collection, we can have different approach to do the iteration. We can use for each loop to do iteration. And you can also iterate the queue using an explicit iterator. Okay. What next is also using explicit iterator and as well as the lambda expression. Okay, so that you can do some formatting with the lambda expression. And what next we did is we call our own search function to search item if the item is in the queue. Okay. Then let's take a look how we implement the search method. So for this search method, it has a target item you want to search, and this is a queue. Okay. So what over here we do is we first create a queue, okay, using linked list. And for this queue, then we call it add all method. And why we can do this is because this add all is from linked list, and the linked list this queue interface also basically it's a sub interface from collection. Okay, and the collection interface, it has the add and add all those methods. So that's why over here, okay, you can directly go ahead to do it. So this add all, it also take the queue. So it can take another collection, okay, and the queue is the type is queue. The queue is sub interface of collection, so that's why this is fine. You can go ahead do it. And after we do that, because this is its own copy, so that's why you can do the remove using the remove operation. Because otherwise, if you don't do this copy, you work on the original, then that will empty out of the original queue. That's not what we want to do, okay? But for the search function, over here, the purpose is try to explain the add all, okay? And basically, because Java collection queue support the for each loop. So when we do search, we can use a for each loop to do the comparison instead of create a new queue and then add the queue to the copy and then do all of the poll. So this is not efficient. Okay. Compare with the way to use for each loop. Okay, and then let's take a look at the examples. We can see the loop using the three different approach output is the same, and also it can find if the item is in the queue or not. Okay. Okay, so that's the second example in this chapter. So that's all for this lecture. We're going to move to the next chapter in our next lecture. See you.